you may remember, we did 407, which is about dividing, okay? And then we sort of skipped over to 409 because I wanted to show you how to do some stuff with calculators. So that's why we're coming back to 408, okay? Now, I want you to have a look at question 13 with me. That's the example that I'm going to go through on the board. I'm going to do it twice. I'm going to do it a bad way, a way that I don't recommend you do it. To indicate that, I will do it in red. And then I'll do it the way that I think you should do it. I'll do that in blue, okay? So for now, just put your pens down and your calculators down, and let's watch while we go through this question, okay? Read with me. 1/6 of the class were a day late with their assignments. Okay, a sixth of the class. They were a day late with their assignments. Keep going. The rest handed them in on time. The rest. What's the rest? If 1/6 were late, what's the rest? 5/6. Good. Okay. 5/6 were late. Sorry, we're on time. 20 students handed their assignments in on time. So these people who are the on time people, 5/6 of them, that was 20 students. Okay? All right, let me keep going. I'm going to answer both questions together. Okay? How many students were in the class and how many students were late in handing in their assignments? Okay. I'm going to look and I'm going to notice, for instance, there are 6th here and 5/6 here. So how much bigger is this number than this number? How much bigger is this number than this number?
5/6.
It's 5 times bigger, isn't it? Does that make sense? This number, this fraction, is 5 times bigger than this one. Is that okay? You said
Yes.
that? Good. Okay. But I want this number, right? So in order to get that, I want it to be 5 times smaller, right? So I'm going to go 20 divided by 5. That's 5 times smaller, isn't it? That's 4. That's how many students were late. Okay? What was the other question? What was the other question?
How many students?
How many in total, wasn't it? That's the on-time students plus the late students. That's 24. Okay, I'm finished. I've answered the question. Okay. Now, there you go, I'm done. Can anyone tell me, why might I put this in red? Why don't I think this is a very good way to solve it, despite the fact that the answer is right? Any suggestions? Yeah, which one?
It might take too long.
That's interesting. What would take too long?
I don't know, just like maybe the other way would be.
Okay, there might be a quicker way. All right, sure. Noah, suggestion?
The setting out of the other way could be like less thingy.
Setting out is important. Can anyone make any other comments about the setting out? Because I think Noah's on the right track here. About this and what's good or bad about it. Really, yeah.
There isn't really much work in that.
Yeah, it's just kind of... I would call this is what I call the random number approach. Okay?
Yeah.
Because look at it. It's really just a collection of numbers, none of which have much to do with each other. Okay? It's a bit like, a montage of scenes in a movie, and it's like, what does this have to do with this? I have no idea. It's it's a bit confusing. Now, there are some other problems with it too. Have a look at this second line with me, right? What does it represent? Do you remember I was explaining it to you? What does it represent? The second line, what is it talking about? Yeah, Leah?
Like the people who had it in the work early.
Yeah, good. Or on time, right? This is the on time line. But there's a big glaring problem with the on time line, namely that it's a lie, right? 5/6 is not equal to 20, right? These are not the same, okay? What I meant was 5/6 of the class was 20 students, okay? So this way, not a good way to approach it, even though the answers are right. I want you to pick up your pens now and let me show you how I would set it out, okay? Now, the way I'm going to do it, sadly, is not faster. It's slower, okay? But I think it's better, and I'm going to try and make the case for that in a second, okay? I'm going to follow this same idea, but I'm going to write it out properly, okay? For instance, okay? This 1/6 at the front, right? What does it mean? What does it stand for? It's not just a random number. It's the part of the class that is late. Okay, so I'm actually going to write that. I don't want the numbers just floating around in space, not meaning anything. I need some words there to actually explain what's going on. Okay. I'm then going to say 5/6 of the class is not late, is on time. Okay. Now I still want to say that 5/6 of the class are 20 students, but I'm going to provide words that make sense of that. Okay. So I'm going to say that equals 20 students. Can you see how this second line is so much more superior to this second line, right? Because this is wrong. 5/6 is not equal to 20. Okay. And not just that, you know what 5/6 of what and 20 of what. Okay. Okay, there's my second line, right? Now, how did I put this together? Where did this line, why did I do this, right? Well, the reason I did this is because there are 5 times as many on-time students as late students. Okay? There are 5 times as many, or another way of saying that is there are 5 times fewer late students than on-time students. So now, because of this statement, I'm going to make this equation. It's equal to 4. But now you can see what the 20 divided by 5 corresponds to and what the 4 corresponds to, right? The 4 is the late students, okay? So I would say there are 4 students who are late, 4 late students. Okay, and you guys might have seen these 3 dots before. It means therefore. I'm trying to put together an argument here, right? Because of this, therefore this. Okay? And from there, I can say, I want to add them together, right? I can say, so there are 20 plus 4 total students. Right? Now, can you see the maths is all the same, right? But the way that I've communicated it is so much clearer. Okay, you can actually see which parts of which numbers are important. This is important because it's the total students. This is important because it's the late students, which is what is being asked for. Whereas over here, it's kind of like just free for all. Just have a guess what's the most important part of it. Okay, so my point is, the maths can be the same, but the way you communicate it makes a real difference.